Good afternoon, everybody. Today, we'll be talking on a topic of biodiversity informatics and citizen science. In fact, this area is quite significant in the present scenario and also in the past. And the informatics part of the biodiversity as well as citizen science has contributed immensely both globally as well as at national level. So I'll be talking some of the basics which relates to biodiversity informatics and also what are the challenges in developing any of the biodiversity informatics application. I will also share some of the studies which we have carried out at IIRS. And in fact, we have been working in this area for almost, I would say, around 20 years. And we know that what all challenges we have faced in developing these type of applications. And of course, I will share some of the recent applications which we have developed. And ultimately, I will give my concluding remarks. Uh, well, everybody knows that biodiversity has got a lot of significance. Why? Because it talks about the basic unit of biodiversity, that is gene, and it goes to species, ecosystem, habitat, landscape at all levels. It talks about in totality. So it has got a lot of significance in various areas, especially the mankind, the human mankind. That is the most important why it has got a lot of significance. And this biodiversity uh, uh, talks about various areas like global food security, nutrition, health, prosperity, climate change. I think almost all the areas have been addressed under biodiversity. I am not sure about the statistics, but according to CBD, around 1.75 million species have been described, and I think there are more than 14 million species which are available in the world. So still, the people are exploring. The taxonomists as well as the biodiversity researchers, they are trying to explore new species so that they can be modeled, and also they can be tagged, geotagged, so that it can be a part of a repository. Well, we have been experienced the loss of biodiversity in many forms. Like, for instance, there is a forest fire, there is a lot of anthropogenic activities, and also because of a lot of exploitation due to medicines for getting the medicines. So you can see that more than 70,000 plant species are being used in traditional and modern medicine. So a lot of exploitation is going on in the biodiversity area. So overall, if you see that the entire community, the human being is exploiting the biodiversity in a big way. So there is important some initiatives has to be there so that we can protect this biodiversity, and ultimately we can map them and take the stock of the overall situation. So I think the biggest initiative globally was the Convention on Biological Diversity, which was signed way back in 1992 during Rio Earth Summit. And I think there are more than 180 countries which are the signatories of the CBT. And the basic thing is to promote the sustainable development for translating the principles of Agenda 21 into reality, and also that we have to see that how this CBD can help biological diversity, which caters to plants, animals, microorganisms, and their ecosystem, but also people, their need for food security, medicines, fresh air, water, shelter, clean and healthy environment. I think it takes care of all the SDG goals, the 17 SDG goals, which are directly or indirectly linked to the biodiversity. So I think this has got a lot of importance in the present scenario, and certainly we have to make our efforts to fulfill the goals of the CBD. One, the first thing is the conservation of biodiversity is one of the most important. There are efforts being made both at the global as well as the national level in order to protect the biodiversity, and also have develop a mechanism to map them and also to conserve them. Of course, there is a sustainable use of the components of biodiversity, and and also the fair and equitable sharing of benefits arising from the use of genetic resources. So these are some of the CBD goals which have been initiated by CBD, and also many countries are following the CBD challenges. Now, the most important part is the challenges in the biodiversity data sets. I think I've been working in this biodiversity informatics for the last 20 years, and in fact, I have experienced a lot of issues in handling the data, in organizing the data, and also there are so many other direct or indirect problems which I have encountered while creating these type of databases. The most important thing is the data quality. I think whatever the data we create, it has to be accurate, because ultimately this data is being accessed by n number of users. So we really have to provide the data quality, that is the access to relevant data. That is the most important. And also the fitness for use or a fitness for purpose. So that is one of the important parameter. I'll be going in details about the data quality part, both in terms of spatial as well as non-spatial. Another important point is the data dispersion. Means that whatever the data, because when you talk about biodiversity, it takes care of gene, species, or let us say plants, animals, microorganisms. You have to put them into a single model. So that itself is a challenge. So how I can make use of the existing data models so that I can put all the data under single platform. And the third part is the data provenance. That is the turning of raw data into useful insight. Means how I can cull out the knowledge from the data. Because you might have seen that the data, if you talk about biodiversity data, if you see a raw data or a data in the form of, or it's an analog data, really you cannot get the information, because it caters to a lot of information, and that information you can only access, or you can only access if it converts into a digital form. So that is the most important thing. And once it gets converted, how that information goes into a knowledge and ultimately goes for a wisdom. So really you have to make your data in such, you have to provide your data in such a way so that it can be accessed at its best. Means it can be used by n number of users for n number of applications. The user could be different, but your data is same, is one. So you have to see that how you are portraying your data so that it can be used in a best optimal way. Biodiversity informatics, if you see as a whole, uh, it talks about, it's an application of informatics techniques to biodiversity data for improved management, presentation, discovery, exploration, and analysis. So basically, you are putting your entire data and making use of ICT technology so that it can be accessed, it can be discovered, it can be catalogued, it can be modeled, everything, and of course, you can do the analytics. So all these different, I would say, the different hierarchies that lies how you organize your data. So basically, when we talk about biodiversity informatics, I think many people have already worked on this, and in fact, this concept came in 1992, which was quite new, and more efforts by the Canadians, where they have brought this concept so that you can address different issues related to biodiversity conservation. Now, if you see that I have written certain W's, like W, what, when, where, and who. So what means It talks about the scientific name and the classification, means you are following a taxonomic classification, which type of taxonomic classification you are providing the data. So all these things has to be, because you are providing the naming to that data. So that naming convention or a taxonomic classification is one of the most important property of any species, whether it is plant or animal. The second thing which is important in this particular framework is when, means if you are talking about a specimen or if you are talking about an observational data, you really have to provide when it was captured. When it was captured is very important, because that once you provide a time domain to a data, then it speaks lot many things, means it talks about phenology, it talks about the climatic condition, everything. So that date of capture provides lot of invisible information which can be attached to this particular data. And then the trends, means if you are having the temporal data, you can really understand the entire the entire details about that particular species. The third part is the location. Location, I think, is also an important area, because when you once you geotag that data, or that you provide that information, and along with elevation, physiography, soil, all these information, if you attach, it is more meaningful, so that people can attach many other information with that particular data. And then the who, that who has collected, the person who has first time collected, from where it has been collected, when it was collected, and what is that this. So all that information provides some of the attributes of biodiversity classification or biodiversity informatics. Now, when I go into the details, there are certain processes involved. See, when you talk about what, means you are collecting the data, so you have to either you can put them, you can take a photograph, you can take you can put them in a herbarium, or you are collecting from some literature. So the most important part of this type of data set is whether it is a primary data or a secondary data, because primary data has got a different significance, the secondary data has got different significance. So you really have to provide that how you are collecting that process. So basically here, if you see, I'm writing about the collection of specimen, means you are providing that information, means where you are, from where you have collected that specimen, whether it has been taken from the literature or from the field. Then second thing is the preparation, means you have to create certain vouchers for the scientific research, so that this paper format is accessible by the people. So basically you are ultimately making an analog preparation of these data sets, which are being preserved as one of the process. The second thing is the once you put them in a form of a like you take that data in the form of analog, you have to digitize them, means you have to digitize, means you have to put them into a computer domain, and for that you have to follow certain guidelines, certain procedures, so that you are able to digitize them in a proper way. And the fourth important thing is the standardized, means when you put your data in the digital form, you really have to see that the data is accessible and it should be interoperable, or you have to adopt certain standards and protocols so that it is interoperable among different users. So basically, you have to see that what type of schemas you are following, what type of formats you are adapting, how you are putting them. Like there is a classic example of Darwin Core, which provides a standard form to create these type of data sets. And in fact, many organizations are making use of Darwin Core to prepare their data sets. And then the last part is the publishing, means how you are disseminating that data. So this entire process has to be made available, so that person who is accessing that data should know the entire history of that data sets. So all these mechanisms have to be made available, so that people can use this data and ultimately perform certain type of value addition. Now I'm going into more details. They are the earlier slides were more of a they only provide the basic level, but this is the more detailed information, means how I'm when I build this application, how I'm organizing my data. That is the most important, because the problem is that when if you are working in a single project, then you might follow certain database. But if you are trying to link with other data, you have to see that how my data should be interoperable to other data sets also. So database provides an important mechanism. And then the quality of the data, the dissemination procedure, how meaningful insights can be derived from the data, how data can be made interoperable and reused, and ultimately the data integration, scalability, portability, and availability is the most important, because that is the prime focus of any BI applications. Now, why database design and schema is important? Because see, when you deal with these type of data, because if I talk about the projects which we have handled at IIRS, they have a different type of data sets, because there could be a data which you are deriving from the field. Like suppose from the field you are getting the information about the species, you are keeping the distribution data, you are keeping the taxonomic information, you are keeping the medicinal importance. There are so many fields you are integrating into the data. So basically, before you start ingesting your data into the database, you have to see what all fields are there, what type of fields are there, how I am able to link those data sets. So all that thing comes under the database design. So basically, you have to first understand the data. Once you see the data, once you see the requirement, accordingly you have to design your data. So there are different stages of database design. The data normalization is one of the most important part, because where you talk about first level of normalization, second level, third level, and then you ultimately go to the to BCNF or this thing. So basically, you have to see that what all entities are there, what all relationships are there, how I can take care of the functional dependencies, how I can take care of referential integrity, because ultimately you have to join or relate all these data sets. So your design is one of the most important, because you cannot change your design again and again, because once you freeze your design, all the data will goes into the data, and it will be difficult for you to change the data once the data is being populated. Because also you have to see the integrity constraint, there should not be any duplicacy, because see here database, why it is important, because you are dealing with thousands of, or I would say millions of data, because once it get populated, the records, the rows are so many, the attributes are so many, there should be a proper check that how you are storing this data, especially the data anomalies and the functional dependencies, because anomalies talks about insertion anomaly, deletion anomaly, updation anomaly. All these anomalies has to be taken care once you design this data. And also the query mechanism, because you must know that what type of the queries will be addressed by the user, because keeping all those things, only then you can able to design a perfect database. And in fact, what I have read in the literature, and in fact I have also experienced, the first and the second design is always wrong. Maybe once you go to the third design or fourth design, they are more accessible and they are more meaningful, and you see that the optimization, the performance level is much better compared to the first or the second design. Another important thing is the multi-dimensional analysis. Multi-dimensional analysis is very important, because you are dealing with so many entities, because or I would say, let us talk about distribution, or you talks about importance, you are talking about the taxonomy, you are talking about so many other attributes, so many attributes are there. So you are dealing with multi-dimensional analysis. So how you can make use of certain concepts like OLAP, or the online analytical processing, these type of things can be used in order to provide the better information to the user. And of course, you should have a mechanism of archiving and storing, because once the data is being created or it is being updated, it has to be regularly archived and it has to be properly stored. Only once you do these steps, they can really provide you much better performance, as well as the usability will be much more. In fact, it can be used in an optimal way. Now, the data quality has also an important parameter, because I think I've been working in some of the project, especially the project on IBIN, where we are handling with lot of different types of data from different organizations, and it is really very difficult for us to really provide the data quality value. So basically, the most important thing is we should know what is the quality of the data. When I talk about spatial data, anything which has got a line, polygon, or point, we really have to provide when the data was created, what is the attribute uncertainty, what is the positional uncertainty, what is the logical consistency. All these parameters provide lot of information. You might be thinking that this may create issues, but this is very important, because errors, if you specify in your data, the user will be ensured that the data which he is using for some other application, what is the error associated with it. Because once he develop a new product, he should know that how the error has been propagated from one stage to another. So that's why this is an important parameter. The second is the errors in non-spatial data, means if the data has been derived from an observation or from a secondary literature, you have to see that whether the data is correct with respect to its synonyms, whether it is correct with respect to its taxonomy, means you have whether it is with the same family, whether it is with same genus. All these parameters has to be seen again and again, because taxonomy is the basic information of any species that has to be correct. So there could be n number of like inconsistency, outliers, high dimensionality, imbalance. There could be n number of errors in the data. So you have to ensure that the you might show less data, but whatever data you should show, it should be correct and it should have some errors, the value with respect to their data quality. So another important part which I have used in my earlier slides is interoperability. Means the basic purpose of interoperability is whatever I am creating, that data should be accessible anyway, and it should be reused by somebody. So I can provide this data in the form of an API. I can provide this data in the form of a web service. I can provide that data in the form of any service which can be reused or reutilized. So that is the most important part of interoperability, because when you develop any of these biodiversity informatics application, you have to ensure that this data should also be used by somebody else. So that, because you cannot provide direct downloading of the data, you can only provide a service. So that service will ensure that it is being consumed, it is being used, and then you can, and whatever updation you do at the system level, that is being reflected in your service also. So these are some of the important areas where we must see that we are providing those type of information to the user. Citizen science, I think it is being used in almost all the areas. The basic definition is that the participation of public participation. Public participation, they can help you to create the data, they can help you to validate the data, they can help you to build the data. So creation, building, in all aspect, people can help you. So that citizen science basically is the participation of a public in your project. So it all depends at what level the public is involved in your citizen science. So there are so many mobile apps, there are so many web platforms which have been developed wherein people are providing lot of information. Like you might have seen, people are making use of social media platform like Twitter, Facebook. Lot of information is coming from there. Similarly, you can develop your own citizen science platform where you can, the volunteers are there to help. So basically, citizen science could be a crowdsourcing, it could be a public PPGIS, it could be citizen science. So there are so many terminologies which are being used. And in fact, citizen science is the only tool which provides real time information, and that information you can use it. Like for instance, there are so many projects like birds like bird watching, or there are so many other projects where people are making use of the citizen science and they are providing the first hand observation data. So if you make use of this information, that information can be further linked to a data quality and it can be used for different application. So citizen science is an effort where public participates to provide you the information which can be used in your project. So it depends what level of information you are providing, or you want that public can help you. So there are so many well-known, like Thomas Jefferson, who was basically has developed a citizen science application, and ultimately he was the first to use the weather observations through these different states, and ultimately it was a citizen science project integrated to a national weather service. There was another project of Therio where they have analyzed the phenology, that is basically the leafing and flowering of plants in springtime. Similarly, Nina Leopard Bradley also worked on historical data to understand the climate change. So basically, this citizen science looks to be simple, but it can provide you a lot of information which can be used for a longer duration project or for a long term project. Now, if you see the involvement of public at different levels, level 1, level 2, level 3, level 4. Level 1 is the citizen is being used as a sensor, and it provides you simple information like he can take a photograph, he can geotag and give some comments. So that is a very basic level of crowdsourcing. There could be a level of involvement up to the level 2, means citizen is used as an interpreter, means he sees a butterfly, he identify that butterfly and geotag it and send it to you, or butterfly or bird, anything. So that is a second level of your involvement. The third level could be that he could be involved in problem definition and data collection, means he can monitor different movement daily, he can study the how the bird is flying in a particular area, you can understand the patterns, those type of information he is a part of your objective. So that is level 3. The extreme citizen science is he is involved in problem definition, he is involved in collection as well as analysis as well as interpretation. So at all level that involvement could be there. So that is the extreme citizen science. So you have to see that up to what level you want to involve citizen science in your project. So I think this is a good initiative. In fact, you will be surprised to know in health GI, especially in COVID, the crowdsourced application, crowdsourced data really helped a lot. And in fact, a lot of data in some of the countries is being collected through citizen science approach. So I just want to emphasize that this particular approach can be adopted in any of those biodiversity projects which you want to undertake or you are involved. Basically, it provides you a first-hand information which is always correct, and it can provide lot of meaningful applications which can be derived. So these are some of the other projects like this nature's calendar, then phenological interpretations, migratory dragonfly project, amphibian monitoring. There are very few which I am showing. In fact, there are some in many more projects which are being executed under citizen science. So these are the application of biodiversity informatics, where you can integrate the citizen science, the field information, the satellite data, the data quality check, put them into a platform, and it can be accessed by a number of people. So only thing is how you are storing it, how you are normalizing it, how you are putting them into a warehouse in, and then putting as an information system. So these are some of the broader way of developing any of the biodiversity applications which are available. So I would like to share some of the initiatives which have been undertaken at IIRS with different under the different teams. First, I would like to tell you is one of the important project which was executed by Dr. P.S. Roy, who was earlier director of IIRS, and he was the project director of this particular project. And in fact, he ultimately made conceptualized this project, where how remote sensing and GIS can be used for biodiversity characterization. And here we have immensely used the satellite data. The most important product of this particular project was the vegetation type of the entire country on 1:50,000, which was a Herculean task. And in fact, with lot of involvement of the stakeholders as well as the collaborator, we could able to achieve this particular objective. The second was the landscape characterization to establish disturbance gradient using remote sensing GIS. Third was the priority areas of biological richness for bioprospecting, and last one is the most important thing is the primary data which was collected from this project. That is 16,000 sample plots was overlaid at different sites, and all this data is available under different portals. So this was, I would like to just mention you that these are a few glimpses of this particular project. It was a joint Department of Space and Department of Biotechnology project. And in fact, it was divided into three phases. First phase was from 1999 to 2003, where all the hotspots were taken into study: Western Himalayas, Western Ghats, Northeast India, Andaman Nicobar Island. Later in the phase two, the Central India, West Bengal, Eastern Ghats, and East Coast was covered. And in the phase three, the Himalayan cold deserts, North India, Northwest India, parts of Deccan Peninsula, and Lakshadweep Islands. So the entire country was covered in the duration of almost, I would say, 11 years of project. And in fact, you can see that the entire country was covered in different phases. And I'm happy to inform you that I was also involved in creating the data. And in fact, there were 90 scientists from 39 lead institutions and universities, and 72 researchers were involved in creating this data. And in fact, there was all ISRO DOS institutes, especially who are involved in space remote sensing application, NRSC, IRS, SAC, RRCs, as well as ADRIN. And there was full support from Botanical Survey of India, Wildlife Institute, GB Pant, and all. So basically, what I'm trying to say is that this was the first time vegetation type mapping for the entire country on 1:50,000 scale. And the approach which was used in this is habitat, then the disturbance regimes, as well as the biodiversity characterization. The most important part is this: the linkage between the satellite data, the field data, as well as the other parameters like landscape character, then social driving forces, ground inventory, ecosystem evaluation. All these parameters were integrated, and ultimately which brought these maps. So you can see that this vegetation type map for the entire country was derived, and wherein 113 vegetation classes was derived. And in fact, this we have the 16 more than 16,000 sample plot which was overlaid, and all the data was organized and is available in the in all the information biodiversity information portals. Now here I would like to give you small information that the sample plots which was collected was based on the random sampling, and where the in fact the stratified random sampling was adopted, where the trees, herbs and shrubs data was collected. So you can see that different type of sample plots was overlaid, and entire data was brought under a single database. So and in fact the lot of derivatives was derived from the raw data, like whether you talk about to TIV, total importance value, or species richness, or biodiversity value, ecosystem uniqueness. So all these derivatives was derived from the raw data. And in fact raw data we had for trees, shrubs and herbs, and in fact there were many tables which provides information for different entities. So all these things were brought together and put them into a single database. So these are some of the outputs of these data sets for phase 1, phase 2 and phase 3. So I think I will not cover more detail on the disturbance index. Maybe I can just tell you few things about disturbance index, where the most important part of this particular work was the use of the vegetation type map. And here we have used the landscape ecological parameters to derive, and here you can see that all like proximity, the fragmentation, all the different parameters was used in order to derive the disturbance index. Similarly, biological richness model was also derived, where the field data was integrated, terrain complexity, the vegetation type, DI, entire thing was brought into the weighted summation model, and this particular product of biological richness was derived. So it has got a lot of importance, and it is being used by many government agencies as well as other forest department and many other organizations are making use of this data for their project. And in fact this data has been provided in the form of services also. So people can directly consume overlay these services which are available in the form of open geospatial OGC services, which can be consumed by anybody directly putting these URLs. So once this particular project was derived, so these two information systems was developed. In fact, the first one was the biodiversity information system, which was at that time called as bisindia.org, wherein we have developed certain component of modules. And here we are mainly focusing on a centralized data, means whatever the data which we have derived from the BCLL data has been kept in the form of biodiversity information system. Another project which was evolved from this was Indian Bioresource Information Network. This was more of a decentralized, wherein you can have the data from different data providers. Wherein BIS we are more only focusing to the outputs which we have created under the biodiversity characterization project. So these two portals was evolved, and at present the biodiversity information system is also available, and all the entire data which has been derived from the BCLL project is available. And in fact there is some modeling tools also like WPS, then also some of the like you can directly generate a biological richness map by making use of multi-criteria analysis. So these are some of the developments related to BIS. And now I would like to focus more on a project called Indian Bioresource Information Network, which is presently accessible, and we are now developing a new portal for this particular with certain different objectives and guidelines. So just to give you a little bit information about IBIN, this is more of a decentralized bioresource database, or I would call it a platform, which is based on a hybrid architecture. And in fact, Here we are also keeping the repository as well as the decentralized mechanism by which any data provider who want to be a part of IBIN can either provide his data into the IBIN system, or from his own resources he can provide that data, which can be available in the form of service. So we are trying to work on the new IBIN portal, where we will provide platform as a service. We will provide different toolkits. There are we are also developing some modeling platform by which user can directly upload his data, do some analysis, and ultimately generate the output. So all those advanced modeling capabilities will be available into new IBIN portal. So I just would like to provide you the how we evolved. In fact, there is a lot of data which has been created by Professor K.N. Ganeshaya Group, that is from University of Agricultural Sciences, Bangalore, and in fact he has a wealth of data on plants, animals, marine, microbial resources. So those data sets have been digitized, and they are nothing but a species data. And the second part of the data is the BCLL data, which is a spatial data. So we are trying to integrate both the data sets together into this portal so that people can make use of this data. And in fact, integrating the two different type of data is always a challenge, because you really don't know the requirements. You really don't know what type of attributes are there in one data and what type of attributes are there in another data. So there were many challenges. So in phase 2, in fact in phase 1 only 2 nodes were there, but in phase 2 we it was started in 12 and 17, and the basic objective was in that is to increase the number of nodes. So now in the phase 2, only the 2 core nodes, IIRS and US Bangalore was there, and there were bricks, means 5 bricks. And the 5 bricks, if you talk about bioresource information centers, we have FRLHT, Calcutta University, IHBT, and NEHU. Now the data sets which they have was totally unique. Like FRLHT is providing the medicinal data, like Calcutta University is providing a chromosomes data, IHBT is providing a high altitude data, NEHU is providing the insect data. So you see the variety of data was there, and it was always a challenge to integrate them into a one common platform. So the biggest thing is how we can put them together, because everybody has got different attributes, everybody has got different qualities. So how we can put them into single domain, that was a challenge. And in fact, I will tell you that how we derived a new data model which we can cater to different type of attributes which are available in different with different data providers. So if you talk about data sets, we had animals, plants, amphibians, reptiles, fungi, butterfly, birds, chemical compositions, parasites, medicinal plants, herbs, and spatial. So a lot of variety of data sets are there, and the data dissemination has to be, we have to provide a proper way of dissemination. So we have also developed certain field guides which can help you to identify a particular species. So we could not create for all the species, but to begin with we have created for some of the species. And in fact US Bangalore is also working on some additional field guides which will be available in the new portal. And also another important thing is the technology is changing day by day. So if we develop certain, like this particular portal was developed in CMS, now we have to see that the technology is evolving, how we can adapt to a new standard. So all those mechanism has to be taken care whenever you create these type of information systems. So this is the new IBIN phase 3, where the focus was to see that how we can take care of the earlier data providers, mean the old bricks, And now we have new bricks, new data providers, that is Forest Survey of India, Wildlife Institute of India, CMAP Lucknow, IHBT Palampur, as well as NRSC. So basically here our main focus, because you can see that in these new bricks we have more spatial data providers. So Forest Survey of India takes care of the forest cover map. Wildlife Institute of India has protected area network. They have biogeographical zones. CMAP is more towards the chromosomes, the chemical structure of the data. Then IHBT Palampur deal with more of high altitude plants, and NRSC has got a lot of different other like land use map, soil, geology, so many other web services are available. So the challenge was that how again we can integrate them together so that we are able to provide information to the user. So there also we had a data quality challenge, how the entire old brick data, old node data, how we can have a data quality tag with all these data sets. Then we have to standardize them, because ultimately it has to be standardized. You have to follow certain protocols so that you can provide the access to these data in a seamless manner. The third is the how we can enrich this data, because if we keep on adding certain new bricks, how the data model can be modified. So these are some of the challenges which we are facing, and we are trying to see that how the common data, means the common requirements which a user need, can be catered. And for that I would like to show you that we have developed a new data model which has been derived from Darwin Core, from ABCD, from this EML, from Plinian Core. There are so many different data models which has got certain speciality with respect to distribution, with respect to ecology, with respect to specimen data. We have cull out some of the important fields, and which can adjust to our requirements. So this is a new data model which has been developed under IBIN, and we are once in fact we had a series of discussions among the our BRICS partners and also the experts, and this particular data model basically takes care of almost all the attributes which is required with respect to any of the species. So this is one of the important achievement of this particular project, and we are following this particular data model to create the data for the entire species. Well, I told you that there are always challenges to provide the data in the form of services. For the spatial data, as I told you that all these maps which have been created from the earlier project, and also the maps which have been created from the data providers, they will be available in the form of WMS services, and even we will provide some leverages to some of the data which can be in the form of WFS or WCS service. But we have to see that what level of information is available, will be made available to the user. So that is the important thing, and we are making use of different type of technologies, whether you talk about database, whether you talk about spatial data, whether you talk about web server, whether you talk about mapping application. We are trying to use the best possible technologies so that the data is accessible to everybody. So for when we talk about citizen science, we have recently created two mobile apps. One is a species loss reporting, which is accessible from our IBIN, the existing IBIN portal, where you can see that some of the species which might be affected due to forest fire or due to any anthropogenic intervention, they can be directly geotagged, and you can provide some information. So these type of things, this mobile apps can be directly downloaded, and in fact they are also associated with a dashboard where you can report these. Another one is a species watch. In fact, any new species which you encounter, you can directly download this mobile app, and you can report this particular species on a dashboard. So this is just we are yet to provide a new IBIN portal in the public domain. This is just in the in the testing phase. And once the new portal will be ready, you can access all the dashboards. In fact, mobile apps at least you can download, and you can give our first hand feedback to us. We have also developed on the fly niche modeling facility within the IBIN portal, where you can upload your points, the species data points, like the occurrence points or the observational points, and accordingly, what are the probable areas where this particular species is likely to be found. I think already the niche modeling is being covered by Dr. Hiten. So these are some of the online tools which are being developed for the new IBIN portal, and in fact they are also available in the present this thing. So these type of niche modeling, as well as the you can also use Google Earth Engine. There are so many technologies which provides a platform by which you can develop, you can do a lot of research, and also you can see the potential of these technologies, which can help you to model some of these. So recently we have worked on Jacobin cuckoo. I think this is my one of the slide. In fact, yesterday Dr. Gautam Talukdar from WI might have covered about this. So this was one of the interesting application of IBIN, and wherein we have tagged two birds, Jacobin cuckoo, and basically they come from Africa, and they are called as harbinger of Indian monsoon. And in fact, you can see their tracks. I have put them, so some of the tracks which we have taken through Argos, and this particular is a real time data which is coming, not a real time, but I would call it a near real time data. And this data points really help us to understand that how this particular species is with its different points, its behavior, how it is adjusting to different climate change scenarios. So we are planning to develop an API. We are planning to develop a location analytical tool where a user can make use of. So at this point of time, we are not providing the accessibility of these data points. I think in the new portal, we will be providing a dashboard where the access mechanism of these services will be available in the public domain. So this is another Android app which has been developed by making use of CNN based model, and this is for the butterfly identification. I think some initiative is already been undertaken by US Bangalore, but this is a small beginning, that how we can make use of MLDL approaches for doing for identifying a species. So this is also another area which narrow down some of the field guides which are available. In fact, these type of mobile apps can be used to help a user to identify a species. And these are, but for them, for developing these type of applications, we need to have a voluminous data. Once the voluminous data is there, it is easy for you to train them to develop these models, and then can provide as an application. But if you have limited data, the accuracy may not be good, because we started with 22 butterflies of Uttarakhand, and now we have made it for 132 butterflies, but we are yet to develop this for all the butterflies of the Indian butterflies, so that once the data, when this data is completed, the training model is developed, this will be available in the new portal. So in the end, I would like to mention that we will be providing this data in the portal, wherein you have all the data available in the form of the grids, and you can integrate the environmental data. You can attach many other dimensions to these data sets, which can ultimately provide you some of the predictions. And also we will try to have a mechanism of a timeline wherein you can monitor some of the the information which is available in the form of a repository as well as in the form of a historical data. So a lot of analytics will be there in this, and we are developing on these grounds, and we will see that once the entire data is completed, the database organization and web development is completed, this will be available in the public domain. So I would like to conclude that biodiversity informatics has got a lot of potential, and in fact it can take care of some of the major objectives of the Convention on Biological Diversity. And in fact it is not limited to some of the areas which I have portrayed, but it has got even much more potential. So only thing is we have to explore that how this informatics, the ICT tools can enhance. Now because of this biodiversity informatics evolution, you might see there are so many portals which are available, and that is because of the sharing of the data. That is because of the data in the public domain with the help of biodiversity informatics. So over a period of time, you will see much more applications which will evolve and ultimately can serve the purpose of the CBD, which many countries are adopting. Citizen science, as I told you, that whether you want to use it for mapping, whether you want to use it for validation, whether you want to use it for modeling, you can use it for many purposes. Only thing you have to see that to what level this data, because this provides you a real-time data. So not only near real time, but I would call it a real time data, which can directly be brought into the into your information system. Another point is that we should have a mechanism of one single portal or a platform where all the stakeholders should share the data, so that because when the user want to access the data, he should not look for n number of portals. There should be a cataloging mechanism. There should be a mechanism by which he directly gets access to the data, because our objective is he should not search for the data. He should, from the single platform, he should able to access whether the data is coming from any other institute. So that should be, there is a good initiative by Indian Biodiversity Portal where they have really worked in a professional way, and from since 2008 I think they are creating this portal, and at this point of time I think a lot of information resides, and they are trying to adapt a good mechanism of sharing the data, and also developing different type of groups wherein they can interact and provide some information to the public. And the last is important thing is the development of interoperable tools and web services and APIs. I think we really have to provide all the data in the form of web services so that it can be accessed at any point of time, whether it is a spatial data or a non-spatial data. And also we have to provide access to the models, because there could be some models which people are unaware. So maybe through a single platform they are able to run that model on that platform and ultimately generate some important information. So with this few words, I think I close my lecture. Thank you very much.